Hi class, we're going to focus on stages of prenatal development and the pre-embryonic stage of this recording. And as we look at pregnancy, it's worth refreshing that we say it's over three-month trimesters, or we can say 40 weeks, or 36 weeks, depending on how you slice and dice it. Full term is typically defined as 40 weeks for the full term of pregnancy, although if a child is born for 36 weeks after conception, generally speaking, the child's going to be just fine. As we look at that first trimester, that's going to be from the point of fertilization through the first 12 weeks. And that assumes a 4-week month, a 28-day month exactly. And as we all know, every month can't be the glorious month of February. So saying weeks versus months, we lose a little bit in translation. As we look at this first trimester, about half of all embryos are going to die from entirely natural causes during the semester. These are referred to as a miscarriage. And as we look at this growing embryo during the first trimester, it's very vulnerable to stress, drugs, nutritional deficiencies, and I'm going to get a little bit of a soapbox right here. One of the things that happens is there's a lot of fetal alcohol syndrome that develops. I used to teach in very rural parts of Wisconsin that had a lot of alcoholism, chronic alcoholism in the communities. And I had children in my classrooms who had fetal alcohol syndrome, and it's not cool. It's very not cool at all. And especially, we'll talk about this more in subsequent recordings, but early on, a lot of times, even before the woman is sure that she's pregnant, she's still consuming alcohol and causing the damage very early on. So these issues that come up are pretty serious during this first trimester. This is the make or break trimester for the rest of the life cycle of this human being. Now, as we look at the second trimester, this second trimester can be kind of hairy. When we look at the second trimester, we're going to have organs developing. At this point, the fetus goes from looking like an alien from Mars to having distinctly human characteristics. We also are going to switch our terminology. Instead of saying embryo, we now say fetus because we've passed the 12-week mark. And there's a chance of survival with very intensive care if born near the end of the second trimester. And I really need to update this. When I initially put this presentation together, I was able to find a figure of a premature birth of someone who was born at 24 weeks, and this is someone I know personally. His name is Sterling, and he was actually just at my house recently playing chase with my kids. But he was born at 24 weeks. But I read in the news recently that a new world record was set of a child who was born at, I want to say 21 or 22 weeks. I can't remember which. Don't quote me on the numbers. But earlier than 24 weeks. And this child made it home from the hospital with no complications from being born so incredibly early, which I find to be absolutely amazing. As we look at week 25 and on, we're now at the third trimester. And generally speaking, if a child is born within the third trimester, that child is probably going to be okay, especially if they are giving birth in a hospital in a developed country that has the standard equipment. I'm thinking of an incubator or a NICU unit. The child is going to be all right. The fetus at this point is going to be growing very rapidly. The organs are going to have much more cellular differentiation so that we can independently support life outside of the womb. And at that 35-week mark, we consider the fetus mature, or at 5.5 pounds. Now, with that said, there's definitely an advantage to baking the bun in the oven a little bit longer. So if we have a child that or fetus that remains in the womb longer than 35 weeks, the 36, 37, 38 weeks, that's not a bad thing. That's a good thing. The issue happens when, or there's issues though, when the fetus remains in the womb longer than full term. Particularly the cranium grows to be too large, so large that it can't pass through the birth canal, at that point in time, we need to get the child out via cesarean section. I had to include a picture of my kiddos. So I have Tim and Ben right here, and they're holding Annabelle, my little girl. And that's a picture of Annabelle when she was 20 minutes old. And I thought it was notable that she was 37 weeks developed. So she was technically full term. And she's just a little cutie. I love my kiddos. Now, as we look at this pre-embryonic state, this pre-embryonic state of development is typically going to be the first 16 days of development, and it's going to involve the development of the germ layers. We're going to get to that germ layer stage, and once those germ layers are there, we're then going to have the embryo. But before we get to that embryo stage, we're going to have some cleavage, implantation, and embryogenesis. So let's talk about those stages. As we look at cleavage, this cleavage is going to involve cleaving the cell in half. So we're going to kind of pinch the cell in half. We have a cleavage furrow form, like this one right here. And that's going to pinch the cell in half. And that one bigger cell is now going to have two smaller cells that are formed that are half the volume. And that first cleavage event is typically going to be about 24 to 30 hours after fertilization. It's going to happen relatively quickly after fertilization. And that zygote is going to split. So we go from a single-celled zygote to the blastomeres stage. And these blastomeres are the daughter cells of the zygote. And just to review and refresh, when we say Conceptus, this is our super generic catch-all term that refers to things that are within that are going to end up within the human body and things that are going to end up outside of the human body, even though they all share the same genome. So think of the child as the human body, but then the amniotic sac, the umbilical cord, and the placenta, these are the outside of the human body, even though they share the same genome as the child. So as we look at the Conceptus, this Conceptus is going to arrive within the uterus about 72 hours after ovulation. And we'll go from this blastomere stage to a morula stage, where we have a solid ball of approximately 16 cells. And it looks kind of like a mulberry. But keep in mind, we have not had implantation yet. And let's go to the next screen here. And because we haven't had implantation yet, there's been no nutrient uptake. And without any nutrient uptake, we can't increase the total volume of this organism. Instead, we are going to, or this pre-embryonic state of these cells. So instead, the cells keep cleaving in half, and the individual cells get smaller and smaller, while the overall volume remains the same. So we have a 4-cell stage, 8-cell stage. Now we have the morula with 16 cells. And after that morula arrives in the uterine cavity, it typically takes 4 to 5 days. By the time it's going to get down here, it's going to be about approximately as it's working its way down, it's going to keep dividing until it gets to be about 100 cells. And then once it gets to be that 100-cell stage, the zona pellucida, that membrane that's been around it, dissolves, and the morula will be converted into a hollow blastocyst. And this hollow sphere, called the blastocyst, is going to then implant. And as we look at the blastocyst, there are a couple layers of cells. The outer layer of cells is called the trophoblast, and it's going to be made of squamous cells. And eventually it's going to become the placenta and play a key role in nourishing the developing embryo. And then the inner mass of cells, so we can see some inner cells right here on the inside. That inner mass of cells is going to be the embryoblast. So the cells on the outside are going to be extra human, so think of amniotic sac, umbilical cord, placenta, and then the cells on the inside are destined to become the main body of the human being that's developing. So as we look at the blastocyst, that hollow ball of cells, we have the trophoblast on the outside, we have the embryoblast on the inside. And of course, there's a hollow place called the blastocoele as well, because why not? And that is going to implant into either the endometrium located within the fundus of the uterus or the endometrium at the posterior wall of the main body of the uterus, usually. Every once in a while, and let's back up a slide here, implantation will occur way down here by the internal os. And if implantation occurs way down there by the internal os, we can have a condition known as placenta previa form. And during that situation, the growing placenta can actually block the exit from the uterus. Thankfully, for my wife's first 2 pregnancies, she did not have any placenta previa. However, for our 3rd and final pregnancy, we had a partial placenta previa. So early on in the first trimester, the internal os was completely blocked off. But as the uterus stretched out and grew throughout the course of the pregnancy, the placenta was pulled off to the side to make room for Annabelle to exit the uterus. And it's going to morph, and we're going to have the formation of the cytotrophoblast and the syncytiotrophoblast, and these cells are going to grow and penetrate into the endometrium. Note we have a uterine gland right here, and this uterine gland is going to secrete glycogen-rich secretions to the growing mass of cells. And then at the end, we have embryogenesis. And embryogenesis is when we have the formation of the 3 primary germ layers, the ecto, meso, and endoderms. And we can see the ectoderm represented by the blue, the mesoderm is this red line, and then the endoderm is represented by this particular line of yellow cells. So not the entire mass of yellow cells, just the particular line along the midsection. As we look at the trophoblast will be continually secreting human chorionic gonadotropin, HCG, throughout the early parts of the pregnancy. And that HCG is going to travel through the bloodstream to the corpus luteum, which is going to be located on the ovary. So on the ovary, there was a follicle, it burst, it ovulated, and then the leftover follicle, after ovulating in the secondary oocyte, turns into the corpus luteum on the ovary, and that corpus luteum is going to secrete estrogen and progesterone. Progesterone suppresses menstruation or promotes the lining of the endometrium, or the lining of the uterus, to be well developed. And we find that human chorionic gonadotropin levels rise, or HCG levels keep going up and up until the end of the 2nd month. By the end of the 2nd month, the placenta is able to produce enough progesterone to maintain the endometrium all by itself. As we look at the trophoblast, that trophoblast is going to develop into a membrane called the chorion. And as we look at that chorion, the chorion eventually will take over the role of the corpus luteum. And that chorion makes it so that we no longer need to have any more HCG, human chorionic gonadotropin. It becomes completely unnecessary. And then the ovaries are going to become, for the most part, relatively inactive for the remainder of the pregnancy. And as we have the increases in hormones within the woman's body, those hormones are going to arise from that chorion directly. So the estrogen and progesterone levels that skyrocket in the female's body are primarily going to be produced by that chorion. That's all we have for this discussion. If you have any questions or comments, please feel free to post them on the class discussion board. And as always, happy studies.